Every advanced chip on the planet, inside your phone, your laptop, every AI server running right now, exists because of one company, ASML, a Dutch firm based in Veldhoven, Netherlands, that builds the only machines on Earth capable of printing the world's most advanced semiconductors. No other company comes close. No other country has cracked it. For 2 decades, ASML sat at the very top of the global technology food chain, completely untouchable. That era is ending, and the way it's ending will reshape everything you know about technology, global power, and who controls the future. Here's what nobody is telling you straight. China controls approximately 90% of the world's rare earth refining capacity. These aren't random rocks. They are the irreplaceable ingredients baked into every single EUV machine ASML produces. The ultra-precise lenses inside these machines require cerium oxide polished to 99.9% purity. Only Chinese refineries consistently hit that number. American operations struggle to even reach 92.9%. The magnetic systems inside each machine use over 10 kilograms of permanent magnets made from neodymium, dysprosium, and terbium. China produces over 90% of those magnets globally. When ASML tried replacing them with ordinary materials in testing, production costs jumped 40% and performance dropped 30%. There is no alternative. There is no workaround. ASML needs China to function. On October 9, 2025, Beijing's Ministry of Commerce announced that any lithography equipment containing just 0.1% or more of Chinese rare earth materials now requires an export license from Beijing, regardless of where it was assembled or shipped. That single percentage captures virtually every advanced chip-making machine on Earth. ASML's chief financial officer Roger Dawson confirmed the company holds enough rare earth inventory to sustain production for approximately 8 weeks. After that buffer runs out, if Chinese export licenses get delayed or denied, monthly output could drop by 15 to 20 machines. With each machine representing hundreds of millions in revenue, annual losses for ASML alone could exceed $3 billion. But this didn't come from nowhere. Rewind to September 30, 2025. Without warning, without evidence, without a proper hearing, Amsterdam's Court of Appeals seized Nexperia, a Chinese-owned semiconductor company operating in Europe. They removed Chinese CEO Kong Shujing, appointed a foreign executive, and transferred 99% of the company's shares to a third-party trust. The Dutch government cited management deficiencies and economic security threat. What they failed to understand was that over 70% of Nexperia's actual production capacity physically sits inside China, in Dongguan and Shanghai. The Dutch grabbed the paperwork. China kept the factories. Beijing's response came exactly 1 week later. Chinese authorities blocked Nexperia's plants from shipping automotive semiconductors to European customers. Capacity utilization at those plants collapsed from 90% to under 10% almost overnight. Delivery capability to European customers crashed from 95% to just 3%. Volkswagen's main plant in Wolfsburg shut down every production line, losing over $100 million per day. BMW's Munich facility watched delivery times on luxury models stretch from 3 months to 6 months. Within 2 weeks, European automakers collectively lost more than $3.5 billion in production output, while approximately 12,000 workers faced layoffs or reduced hours. Honda announced shutdowns at multiple North American plants, with one facility in Ontario, Canada cutting production capacity in half indefinitely. Meanwhile, on the other side of this war, China has been building something the West said was impossible. In early 2025, inside a secured laboratory in Shenzhen, Chinese scientists completed a working prototype of a domestic EUV lithography machine. A machine that generates the 13.5 nanometer wavelength light required to etch circuits thousands of times thinner than a human hair onto silicon wafers. ASML's CEO Christophe Fouquet told investors in December 2024 that China would need many years to develop this technology. That statement is now being torn apart by the evidence. The man central to this breakthrough is Lin Nan, formerly ASML's head of light source technology. Lin spent over 5 years at ASML Research before returning to China in April 2021. His team filed 8 patents on EUV light sources in just 18 months. Their research published in December 2024 showed they achieved 3.42% conversion efficiency in generating EUV light, actually surpassing the 3.2% achieved by the Advanced Research Center in the Netherlands. China invested between $37 billion and $40 billion into indigenous EUV development. The explicit target is to produce working chips on entirely China-made machines, completely eliminating reliance on American-controlled supply chains. Beijing officially targets 2028 for working chip production from this prototype. And then there's Huawei. In 2019, the US cut Huawei off from Google, Android, and advanced chip manufacturing. Every expert predicted it would destroy them. By 2025, over 900 million devices run on Huawei's own operating system. Huawei just tested a machine that only one company on the entire planet has ever been able to build. Not copy. Not reverse engineer. Build. From scratch. And the experts who said this would take China at least 15 years are now watching their own predictions fall apart in real time. Here's the thing though. Before you believe the hype, you need to understand what's actually confirmed, what's still unproven, and why the real story is more interesting than any headline you've seen this week. Let's start with the machine itself. An EUV lithography machine is not a piece of factory equipment. It is the most complex object human beings have ever manufactured. Each one costs over $350 million, more than a Boeing 787 Dreamliner. It weighs 180 tons and needs 40 shipping containers just to move it. Inside, it fires a high-powered laser at tiny droplets of liquid tin to create plasma that emits light at a wavelength of exactly 13.5 nanometers. That light is then used to etch circuits onto silicon wafers. Those circuits are 30,000 times thinner than a single human hair. Only one company in the world, ASML, a Dutch firm, has ever successfully built these machines. It took them over 20 years and a global supply chain of more than 5,000 suppliers across Europe, the US, and Japan. That is what Huawei is trying to replicate. In 2019, the Trump administration put Huawei on the Entity List. Every American supplier, every chip partner, every software vendor was legally cut off overnight. Then Washington pressured the Netherlands to stop ASML from shipping EUV machines to China. Huawei's manufacturing partner, SMIC, Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which physically cannot produce chips smaller than 7 nanometers. The sanctions looked airtight. Western analysts called it game over. Then in 2023, Huawei shipped the Mate 60 Pro. A real 7 nanometers chip, made in China, without a single ASML EUV machine. TechInsights, the leading semiconductor research firm, tore the phone apart and confirmed it. SMIC had achieved this using a technique called multi-patterning, essentially drawing the same circuit lines multiple times with older DUV equipment to get finer resolution. Something the entire industry said the physics wouldn't allow. It happened anyway. Now in 2025, Huawei is testing something that goes far beyond that. They've built their own EUV machine using a completely different approach called laser-induced discharge plasma, or LDP. Here's how it works. ASML's method fires a laser at tin droplets to create plasma. Huawei's LDP method vaporizes tin between 2 electrodes and hits it with a high-voltage electrical discharge instead. Different mechanism, same result, 13.5 nanometer wavelength EUV light, the exact frequency needed to etch 3 nanometer circuit. The design is simpler, smaller, and potentially a fraction of ASML's price. A patent for this technology was filed with China's National Intellectual Property Administration in 2023. Trial production is targeting Q3 2025. Mass production is targeting 2026. Now here is where we slow down and fact-check. The patent is real. Multiple independent Chinese research teams, including one at the Shanghai Institute of Optics and Fine Mechanics and another at Harbin, have separately confirmed achieving 13.5 nanometers light source breakthroughs. That part checks out. What has not been independently verified is whether this machine actually works at commercial scale. There has been no third-party teardown, no external confirmation of output quality. The sources are patents, leaks, and state-adjacent media. So the technology concept is scientifically sound. Whether it performs reliably in a factory environment is a completely different question. The number that matters most here is yield rate. If you make 100 chips and 90 work, your yield is 90%. Commercial viability requires at least 70%. TSMC runs at 90% plus on its 7 nanometers process using EUV. SMIC doing the same 7 nanometers node with DUV multi-patterning hits around 50%. At 5 nanometers that drops to roughly 30%. At 3 nanometers using this new method, analysts estimate initial yields could be as low as 10 to 15%. That means 85 to 90 chips out of every 100 fail. Each working chip becomes extraordinarily expensive, even after China's government subsidies covering around 30% of production costs. This is the part most videos won't tell you. A patent is not a product. A lab breakthrough is not a factory. But here's what you also cannot ignore. NVIDIA, the company with a $5 trillion market cap that powers almost every major AI model on the planet, warned its own investors about Huawei's gains. That is a legal disclosure, not a press release. When Huawei announced the Ascend 910C, a chip that reportedly matches the performance of NVIDIA's H100, NVIDIA's market value dropped $127 billion in a single day. Then researchers at Peking University published a paper in Nature Electronics describing an analog computing chip that processes matrix calculations 1,000 times faster than the NVIDIA H100 while consuming 100 times less power, and they built it using 7 nanometers technology that the US never sanctioned because everyone assumed it was too outdated to matter. Jensen Huang, the CEO of NVIDIA, stood on stage at the Financial Times AI Summit in London and said directly, "China is going to win the AI race. Not might win. Will win." So here is the honest verdict. The 15-year gap is fiction. That is confirmed. 3 nanometers chips flooding the market by 2026 is also probably fiction. In March 2025, photos leaked from inside a Huawei facility in Dongguan, China. Engineers around the world opened those images expecting to find nothing. What they found instead made ASML's stock drop 7% in a single session. There was a machine sitting inside a clean room that, according to every Western semiconductor expert alive, should not exist. China had built its own EUV lithography machine. Then 3 weeks later, researchers at Fudan University published a paper in Nature describing a chip with an active layer thinner than 1 nanometer. 2 breakthroughs, 1 spring. And the blockade the United States spent years constructing started showing cracks that nobody can explain away anymore. To understand why this matters, you need to understand what ASML actually is. This quiet Dutch company based in Eindhoven makes exactly one product: extreme ultraviolet lithography machines. Every iPhone ever made, every NVIDIA GPU powering ChatGPT, Claude, every AI model you've touched. None of it exists without ASML. Their machines fire a 30 kilowatt laser at microscopic tin droplets 50,000 times per second, generating plasma hotter than the surface of the sun, releasing light at a wavelength of 13.5 nanometers that etches circuits onto silicon with atomic precision. Each machine costs $380 million, weighs 150,000 kilograms, requires 250 shipping crates just to transport, and is assembled from over 100,000 parts sourced from 800 suppliers across the world. ASML spent over 20 years building this technology. In 2019, the United States turned it into a weapon, pressuring the Netherlands to block all EUV exports to China. The logic was simple and seemingly airtight. No EUV, no chips below 7 nanometers, no advanced semiconductors, no AI dominance. Game over for Beijing. Then August 2023 happened. Huawei released the Mate 60 Pro. Tech Insights, the most respected semiconductor research firm in the world, bought units, cracked them open, and confirmed what looked impossible: a genuine 7nm Kirin 9000S chip, manufactured inside China by SMIC without a single ASML EUV machine involved. SMIC did it using older DUV deep ultraviolet equipment and a technique called quadruple patterning, running 34 lithography steps where EUV needs only 9. One engineer described it as painting the Mona Lisa with a house brush. It works. It costs 40 to 50% more per chip than TSMC's equivalent. Yields sit below 50%. By any normal business logic, it's financial suicide. But Beijing isn't running normal business logic. Between 2022 and 2024, the government funneled over $75 billion into domestic semiconductor development. Government subsidies covered 87% of SMIC's entire operating profit in 2024. More than 50,000 engineers were pulled from companies like Huawei and SMIC and redirected into classified research facilities. This was never about profit. It was always about making sure no foreign government could ever again threaten to switch off China's entire technology sector with a policy memo. Now back to Fudan University. The chip is called Wuji, a 32-bit RISC-V microprocessor built not from traditional silicon but from a 2D material called molybdenum disulfide. Its active layer measures less than 1 nanometer thick. It contains 5,900 transistors. The previous world record for a 2D semiconductor circuit was 115 transistors, set in 2017 by researchers at Vienna University of Technology. Fudan didn't inch past that record. They cleared it by a factor of 51 in a single leap. The same team built a flash memory device called POX that writes data in 400 picoseconds, roughly 25 billion operations per second, with a 94.3% yield rate in controlled lab conditions. Here's the honest truth though, this chip cannot run an app. It cannot power a phone. It cannot train an AI model. There are 80 billion transistors inside a modern processor. 5,900 is not a gap from that number. It's a canyon. What Fudan proved is that the physics work at atomic scale using 2D materials. What they didn't prove is that anyone on Earth can manufacture this at volume, because nobody can yet. But here's what matters. Every hard line drawn around what China could not do has been crossed. 7 nanometers without EUV was physically impossible. It happened. The 1 nanometer research is the flag planted for the next decade. Back to those photos from Dingguan. The equipment spotted inside Huawei's facility was traced to the Chongqing Institute of Optics. The underlying technology is called LIDP, a laser-induced discharge plasma, developed at Harbin Institute of Technology. Instead of blasting tin droplets with a massive laser the way ASML does, the LIDP method vaporizes tin between two electrodes using high-voltage electrical discharge, producing the exact same 13.5 nanometer EUV radiation through a completely different mechanism, one that reportedly consumes 40% less power than ASML's approach. Current LIDP prototypes produce between 50 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's latest machines push past 500 watts. The gap is real. Chinese officials targeted trial production for Q3 2025 and mass manufacturing for 2026. Independent analysts say 2028 to 2030 is more realistic. These are the same analysts who said 7 nanometers without EUV was impossible. That context is everything. Even a machine producing 70% of ASML's output would be revolutionary for SMIC, which is currently burning through 34-step workarounds that make every chip they produce dramatically more expensive than anything coming out of Taiwan. And TSMC is watching. In the second half of 2025, TSMC began mass production of 2-nanometer chips using gate-all-around transistor technology for the first time, with yields reportedly above 60%. Apple, Nvidia, and AMD already locked in capacity. Samsung entered 2 nanometers production too, but is stuck around 40% yield compared to TSMC's 90% at 3 nanometers, a gap that translates to billions in wasted silicon every single month. TSMC itself says it won't reach 1.4 nanometers until 2028, and true 1-nanometer mass production isn't expected before 2030. Every step of that roadmap depends entirely on ASML machines that China cannot legally buy. Meanwhile, Huawei's Ascend 910C is already shipping at roughly 780 to 800 teraflops of BF16 performance, about 40% of Nvidia's H100 at 2000 teraflop. Huawei plans to ship over 700,000 Ascend units in 2025 alone, scaling to 1.6 million chip dies by 2026. The next chip, the Ascend 910D, reportedly targets H100 level performance on specific workload. When that report circulated on April 28, 2025, Nvidia lost 2% of its market value in a single trading day before a single specification was independently verified. China currently depends on foreign chips for 60 to 70% of its AI infrastructure. By 2026, analysts project that falls to 40 to 50% as Ascend production scales. The direction is not reversing. The 1-nanometer chip is real science. The EUV machine is a real prototype. The gap is real and measured in years. But the team trying to close it has $75 billion, 50,000 dedicated engineers, and absolutely nothing to lose. Watch this space. On December 6, 2025, a patent quietly published by China's National Intellectual Property Administration stopped semiconductor executives cold. The document's title was Dry and Bureaucratic: Metal Integration Method for Manufacturing Integrated Devices, and for a few hours nobody noticed it. Then the engineers started reading. And the silence became panic. Because buried inside that filing was something that should not exist. A detailed technical blueprint from Huawei, the Chinese tech giant locked out of advanced chip-making equipment since 2019 for manufacturing 2-nanometer chip. The same cutting-edge technology that TSMC, Samsung, and Intel collectively poured over $100 billion into developing. Except Huawei is claiming they can do it without the machines they are legally banned from buying. To understand why that matters, you need to understand the machines. ASML, a Dutch company, is the only manufacturer on Earth of EUV lithography machines, the absolute gatekeepers to advanced chip production. Each one costs over $150 million. They weigh 180 tons. They require 40 shipping containers just to transport. Inside, they fire laser-produced plasma at tin droplets to generate light with a wavelength of just 13.5 nanometers. A beam so precise it etches circuit patterns onto silicon that make a human hair look like a highway. The entire semiconductor industry agreed on one thing. Without EUV, you cannot manufacture chips below 7 nanometers. That was not an opinion. That was physics. Only TSMC, Samsung, and Intel had these machines. In 2022, the Netherlands blocked ASML from selling to China. The cage was complete. Then Huawei started doing things that were not supposed to happen. In August 2023, they released the Mate 60 Pro smartphone. Western analysts tore it apart looking for the trick. There was no trick. Inside sat a genuine 7nm Kirin 9000S chip, manufactured by SMIC, China's largest chipmaker, using older DUV deep ultraviolet lithography machines that nobody had bothered to sanction because everyone assumed they were too primitive to matter. TechInsights, the leading semiconductor research firm, confirmed it after a full teardown. 0 ASML. 0 EUV. A chip that defied a decade of Western assumptions, shipping in a phone that sold out within minutes. Then in 2024, the Kirin 9030 pushed toward 5nm equivalent performance. Every time the world drew a line and said China cannot cross this, Huawei and SMIC crossed it anyway. So what exactly is in this new patent? The method is called self-aligned quadruple patterning, or SAQP. The idea is ruthlessly simple in concept and brutally complex in execution. EUV draws an ultrafine circuit line in one single laser pass. SAQP draws that exact same line in 4 separate passes using older DUV equipment, with precision-engineered stencils and spacers guiding each pass down to atomic-level accuracy. The patent describes 5 spacer layers and exotic metals, ruthenium, copper, and cobalt, woven together to create metal interconnects spaced less than 21 nanometers apart. On paper, it is a work of engineering genius. In practice, it is one of the most expensive gambles in the history of chip manufacturing. Here is the brutal math. TSMC running their 7nm process with EUV achieves around 90% yield, meaning 90 out of every 100 chips they produce work perfectly. SMIC doing the same 7nm node with DUV multi-patterning hits only 50%. Drop to 5 nanometers and that bleeds down to 30%. Now push all the way to 2 nanometers. Industry analysts estimate initial yields using Huawei's method could fall as low as 10 to 15%. That means 85 to 90 chips dying on the production line for every one that survived. Chinese-made chips already cost roughly 40% more than an equivalent TSMC chip, even after Beijing subsidizes around 30% of production costs. At a 10% survival rate on 2 nanometers, each working chip becomes extraordinarily expensive. And China is doing it anyway. Because this was never a business decision. Between 2022 and 2024, Beijing funneled over $75 billion into domestic semiconductor development through state banks, sovereign wealth funds, and tax incentive. More than 50,000 of China's brightest engineers were reassigned from companies like Huawei and SMIC into classified research facilities. In 2024 alone, government subsidies covered roughly 87% of SMIC's entire operating profit. Beijing is not building chips to make money. It is building chips to make sure no foreign government can ever again threaten to switch off China's entire technology sector with a single policy memo. That is a different calculation entirely, and no amount of economic logic changes it. But the patent is only half the story. In early 2025, reports emerged that China was testing its own extreme ultraviolet lithography machine, a prototype believed to be codenamed Hyperion 1, at Huawei's Dongguan facility. The approach is completely different from ASML's method. Instead of firing high-powered lasers at tin droplets, the Chinese system vaporizes tin between electrodes using high-voltage electrical discharge, a technique called laser-induced discharge plasma, or LDP. Both methods generate the same 13.5 nanometer EUV wavelength needed for advanced chip etching. The current prototype produces between 100 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's machines produce over 500 watts. The gap is real, but the fact the prototype exists at all was enough to send ASML's stock down 7% the day the news leaked. Meanwhile, TSMC is not standing still. Their 2-nanometer process entered mass production in 2025 using next-generation EUV with high numerical aperture optics and gate-all-around transistor architecture. They spent over $40 billion on R&D and new fabrication facilities. Their yield from day one sits at 85 to 90%. Their customer list reads like a who's who of global technology: Apple, Nvidia, AMD, Qualcomm. TSMC controls approximately 60% of the global foundry market and nearly 90% of advanced chip manufacturing. None of those customers are leaving anytime soon. But if Huawei cracks 2 nanometers production, even at higher cost, they can supply China's domestic market of 1.4 billion consumers. Companies like Xiaomi, BYD, Alibaba, and ByteDance would route to Chinese foundries instead. That is potentially 30 to 40% of global semiconductor demand, shifting ecosystems permanently. A patent is not a chip. There is zero evidence today of actual 2 nanometers chips being produced at any scale using this method. Going from patent to mass production typically takes 5 to 7 years minimum, and TSMC spent 30 years building relationships with over 600 global suppliers to get where they are. That ecosystem cannot be rebuilt overnight. But here is the thing nobody can argue with anymore. In 2019, a 7 nanometers chip without EUV was called physically impossible. It existed by 2023. A 5 nanometers equivalent without EUV was called physically impossible. It happened in 2024. The 2 nanometers patent may be the next chapter in that same story. Or it may sit in a drawer and never see production. Nobody actually knows. But the wall that everyone said was unbreakable, it has cracks in it now. And the next 24 months will tell us exactly how deep those cracks go. The year is 2025, and something impossible just happened in a secret facility in Dongguan, China. Huawei, the company that was supposed to be dead after US sanctions, just successfully tested their own extreme ultraviolet lithography machine. If you don't know what that means, let me put it simply. They just built the most complex piece of technology on planet Earth, a machine that only one company in the entire world has been able to manufacture until now. And they're using it to make 3 nanometer chip. The same experts who said this would take China 15 years are now watching their predictions crumble in real time. Let me explain why this is absolutely insane. An EUV machine is not just another piece of factory equipment. These machines cost over $350 million each, more expensive than a Boeing 787 Dreamliner. They require 40 shipping containers just to transport. Inside, they use light with a wavelength of exactly 13.5 nanometers to etch circuits onto silicon wafers that are 30,000 times thinner than a human hair. For decades, only ASML, a Dutch company, could build these machines. They had a complete monopoly. No competition. Zero. And when the US government pressured the Netherlands to stop selling these machines to China in 2019, everyone thought China's semiconductor dreams were finished. Here's what happened instead. In 2019, the Trump administration hit Huawei with sanctions, cutting them off from American technology and advanced chip tools. ASML, under pressure, stopped shipping EUV machines to China. Huawei's chip-making partner SMIC, which stands for Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which maxes out at 7 nanometers. The sanctions appeared to work perfectly. China's access to cutting-edge chip technology was completely blocked. Western analysts, semiconductor experts, and policymakers all agreed this was game over for China's chip ambitions. But instead of giving up, China went into full wartime mode. They poured billions of dollars into research and development. Xi Jinping made semiconductor independence a national security priority, comparable to food security or energy independence. Universities, private companies, and state-owned enterprises were coordinated in a massive push toward technological self-reliance. And now, in 2025, we're seeing the result. Huawei didn't just try to copy ASML's approach. They invented something completely different called laser-induced discharge plasma, or LDP. While ASML uses laser-produced plasma that blasts tin droplets with high-powered lasers, Huawei's LDP method vaporizes tin between electrodes and zaps it with high-voltage discharge. This creates plasma that emits the exact same 13.5 nanometer wavelength of extreme ultraviolet light needed for chip manufacturing, but through a fundamentally different mechanism. And here's the kicker. It's simpler, smaller, and potentially much cheaper than ASML's hulking machines. This LDP-based EUV system is already in testing at Huawei's Dongguan facility. A Chinese firm, rumored to be China's lithography champion, filed a patent for this technology in 2023, and now it's coming to life. Trial production is scheduled for the third quarter of 2025, which is just months away. Mass production is targeting 2026. If this works, China could flood the market with homegrown 3-nanometer chips, completely smashing the sanctions wall that was supposed to contain them for the next decade. But this isn't just about Huawei. SMIC, China's top foundry, is in on this too. Together, they're not just trying to catch up. They're aiming to leapfrog Western technology entirely. A South China Morning Post report highlighted that a Harbin team achieved an EUV light source breakthrough, also hitting that critical 13.5 nanometer mark. Meanwhile, the Shanghai Institute of Optics and Fine Mechanics, led by researcher Lin Nan, developed an extreme ultraviolet light source platform with power output and operational stability that specialists describe as internationally competitive. Multiple research teams across China have simultaneously achieved breakthroughs in different aspects of EUV technology, including light sources, optics, and lithography systems. This coordination suggests a well-orchestrated national strategy rather than isolated research effort. Now let me explain why 3 nanometers matters so much. Smaller chips mean exponentially more power with less energy consumption.